Next up in our series is 3.4, complex zeros. So this is where we put it all together. So a polynomial function of x with degree n has n complex zeros. So that's how many total zeros they have. We have talked about zeros before, but now we're going to talk about sometimes they can be real and non-real. So we are going to talk about more imaginary stuff today. And so if f of k is a polynomial where the degree is greater than 0, then f of x has precisely n linear factors. So a linear factor is just where it's like x minus 1. That would be a linear factor. And we have as many of those as our degree. Okay, so here are some other things that we need to note. So x equals k is a solution or a root. Remember, there's 4 different words that mean the same thing. Of f of x equals 0. K is a function, is a 0 of the function. And lastly, x minus k is a factor of f of x. Okay. Another theorem, so all of this front part is just all the fun stuff, definitions. If I know that a plus square root of b is a 0, then I know, or a root is what they're using as the word, then I know that a minus square root of b also has to be a root. So kind of think about quadratic formula where it's negative b plus or minus. So I have the plus or the minus. The same thing is true for imaginary numbers. So if a plus bi is a 0, then so is a minus bi. What does that look like with examples here? So it says find a cubic polynomial with the roots at x equals square root of 2 and x equals 5. So, and then leave it in factored form. You may be thinking to yourself, cubic, that's x cubed. That means I should have 3. I have 1, 2. This is where I use that theorem above that says, hey, if I know square root of 2 is a solution, then negative square root of 2 also has to be a solution. And then I have x equals 5. Now I have 3 different ones. And so to find the factored form, we set each of those equal to 0. So I would subtract square root of 2 for factor number 1. I would add square root of 2 for factor number 2. And then I would subtract 5 for factor number 3. So this is left in factored form. So this is a cubic polynomial because I have 1, 2, 3 x's to the first power. So that's x cubed. If I wanted to put it more in something that you've probably seen before, as far as like x cubed plus this minus that, I would just need to multiply all 3 of those together. But since it says leave in factored form, we're going to be finished there. Yay. And let's do one more together before I close out this video. So let's write the polynomial in standard form and identify the zeros of the function and the x-intercepts of its graph. All right. So I could multiply the first guy by the second guy. That's fine. But remember that multiplication is associative. So I could actually do x minus I square root of 3 times x plus I square root of 3. So I'm doing box method over here for those of you who haven't figured it out. Because This will actually make it simplify nicer. So x times x is x squared. X times negative I square root of 3 is negative xi square root of 3. This is just the positive of that. And then the most complicated, negative I square root of 3 times I square root of 3. So negative I times I is negative I squared. Square root of 3 times square root of 3 is 3. There's a lot more work that could be done here. So remember, this is a note from Algebra 2, that I squared equals negative 1. So I actually have negative 1 times 3, which is just positive 3 for that corner. So all that worked, and I have x squared plus 3. And then I have x plus 2. So maybe you do box method again. If you don't like box method, this is where you would FOIL or distribute. So now I have x cubed, 3x, 2x squared, and 6 for a final answer of x cubed plus 2x squared plus 3x plus 6. So I'm going to set that equal to f of x to call it a function. So I have switched my factor form into standard form. My zeros are negative 2, I square root of 3, and negative I square root of 3. And this one right here is the only one that's going to cross the x-axis because the other two are imaginary. All right, this will close out the first video. I've been talking and rambling long enough. Take a breath, stretch your hand, get ready for the next video.